Hey guys, welcome to our topic on complex numbers. You can follow this on pages 95 through 98 in your notes packet. Okay, so complex numbers are based off of the imaginary unit I. Okay, so back in Algebra 2, you guys were introduced to I, and I is basically the square root of -1. And so basically, anytime you square root a negative, you end up with an I, which kind of represents, hey, we know that I can't really find two numbers that multiply to be a negative, but two I's would combine to make a single negative, okay? And the term complex numbers comes from the fact that we can have numbers that have an imaginary part and a real part, right? And the way they write that usually is a plus bi. You can see it here, all right? So where a and b are just some kind of constant number, okay? So you might have 3 plus 2i, all right? Or you might have -2 plus I, something of that nature, right? So these are just some examples of what complex numbers could look like. So if we keep looking at this, we say, hey, a complex number is a combination of a real number, and bi, the imaginary part, right? And a plus bi is considered to be the normal way of writing it. We always put I last. So a plus bi, this is standard form, okay? And I is last, okay? Just a good habit to be in. Always put things in standard form. That's going to be the way we work through math. Now, anytime you have only that bi section, right, no normal number in front of it, we call that a pure imaginary number, okay? And if we had only a real portion, we would call it a real number, all right? Okay, the cool thing about these is real and imaginary numbers don't really mix together well. So when we add and subtract, they're always going to be real goes with real and imaginary goes with imaginary. And that means that if you have a complex number equality, you know that the real portion must equal the real piece and the imaginary portion must equal the imaginary. So I'm going to give an example of that first, and then we'll try an addition problem. So for example, if I had 3 plus bi equals x plus 2i, we can very simply determine that, hey, this x has to go with the 3. It's the portion that doesn't have an I. So x is going to be 3. And this bi portion matches up with the 2i. So the b must equal 2. So just note, real equals real, imaginary equals imaginary. You can split up that complex number equation into something a little easier to work with. All right. Okay, now let's look at our addition problem at the bottom. Okay. Again, real with real, imaginary with imaginary. Don't mix the two together. So in this case, I'm adding the two together. So 4 plus 1 is going to give me 5, and 7i minus 6i is going to give me plus a single I. Okay, so we get 5 plus I. And the usual rules for subtraction also apply. So if you see a subtraction with the parentheses around it, make sure that you distribute that subtraction throughout. Okay, let's look at multiplying complex numbers. Okay, so just like we've multiplied binomials and variables together when we distributed, we can do very similar things with complex numbers. Okay, so before we even get to that, we really have to know what the exponents of I do. Okay, and in this table, they've kind of worked it out for you, but real quick, we'll just kind of refresh through some of that math. Okay, so we know that I is the square root of -1. Well, that means that I squared is the square root of -1 squared, which means that this is actually just -1 when my square root and this square cancel each other out. And similarly, as I go down the sequence, right, up to I cubed and I to the 4th, we're going to discover that actually each step of the way, I'm going to multiply this previous number by I. And I end up with this, oh, look, this becomes -1 times I, which is -I. And if I do it again, I get this -I squared, which turns into being positive 1 again. Okay, the two negatives cancel each other out. You get negative, negative 1, which becomes positive 1. Okay, now it's not super relevant for us to calculate this out all the time because this pattern always repeats itself. Okay, and they've kind of mentioned that kindly for us in this table right over here in this column. So as long as we have this table, kind of this pattern memorized, we should be good to go. So let's look at what this can do for us in terms of some examples, right? We've got to be able to use this to help us break down some of these i's with exponents on them. So the first example you'll see under these tables is saying, hey, can you figure out what the value of I to the 54th power is? And normally we would see such a big exponent and kind of freak out because it would be a lot of multiplying. But really, it's not too bad because I know that my answer needs to be one of these four values, I, -1, -I, or +1. My answer has to be one of those. And the way the pattern goes, I could kind of count all the way up to 54 if I wanted to, going, oh, 1, 2, 3, 4, and then starting my pattern all over again, 5, 6, 7, 8. But instead, we can very simply just do this. We can take 54 and we're going to divide this by 4. So 54 divided by 4. And we should end up getting that this is 13 with a remainder of 2 or 13.5. So depending on how you did it, if you did it by hand, you might get 13 remainder 2, or if you use a calculator, you might get 13.5. And once you've got that 0.5, you can come look at this little table and it tells you that that would actually have been in this second spot on my table, which means what's my answer? It's got to be this number right here, -1. So I to the 54th power is just equal to -1. And that's it. All we're going to do is we're going to look at our exponent, divide it by 4. Always 4 because there's 4 terms in the pattern. And we'll be able to use that remainder to figure out what our resulting value is. Let's go ahead and give another example a shot. Let's try the next example, which says I to the 14th power. Okay, so again, we want to start with that exponent, 14, and we're going to divide it by 4, and we should get this as 3.5. Again, we don't care about the whole number part. We really care about this remainder of 0.5. So what does that mean? A remainder of 0.5, as it says on my table, is going to be -1. So I to the 14th is just -1. All right. So for the last example on here, go ahead and try it yourself. It says I to the 103 power. So pause the video, go ahead and give this a shot yourself and see if you get the right answer. Remember again, all we had to do was take the 103, divide by 4, and I would have gotten 25.75. And that remainder, 0.75, indicates what? I am equal to I to the third with this remainder, and that value was -I. So I to the 103rd power is -I. Now let's note, guys, we never leave I to any kind of higher exponent. Always simplify I down to a simpler form. So you should never have an I that's to the third, second, anything. You only have I or you have normal numbers. So no I squareds in your final answers, guys. Okay, now that we've talked about how the exponents on I work, we can actually do some multiplication, right? We're going to have to rely on all of those foiling rules and stuff that we did when we were distributing. We're going to kind of approach it the same way, okay? So if we looked at example 1 minus 6I times 4 plus 7I. Let's go ahead and distribute this out. So 1 times 4 is 4. 1 times 7I is going to be 7I. Negative 6I times 4 is going to be minus 24I. And then finally, we've got -6 times 7 negative 42i squared. Okay. Now, from here, we know we can combine like terms, but we're also going to be able to simplify something else here. So watch, here we go. Middle two terms are alike, 7i and negative 24i. Those are going to give me minus 17i. All right. Now, here's kind of the funny one. I squared. Wait a minute. I squared is always just negative 1, which means if I changed this out for a negative 1, negative 42 times negative 1 is actually just going to become plus 42, okay? And basically, I squared always just turns into negative 1 and flips that sign, okay? So if you remember that, you can always shortcut it, but you should just remember this detail. We don't want things as I squared. We want them as normal numbers or i's, okay? So that becomes a 42, and we've got this 4. Is there anything else I can still combine on this? Absolutely. Keep an eye out for the 4 and that 42. We can put those two together and get my final answer of 46 minus 17i. Okay? So watch out. We want to make sure that we distribute and make sure to simplify this and get rid of that I squared. So having seen our previous example, go ahead and try the second problem. Okay? Now we're going to have to start by doing the square, and then we'll be able to FOIL this out. So take a minute, see if you can start by doing 2 minus 3i times 2 minus 3i. Remember to distribute and simplify first. Okay, hopefully as we distributed this, you got 4 minus 6i minus 6i plus 9i squared. Okay, and we're going to go ahead and also combine these two to be minus 12i. And this I squared is going to make this a minus 9 instead. So 4 minus 9 is negative 5. All right. So this first portion right here, 2 minus 3i squared, is going to be 5 minus 12i. And now I'm going to go ahead and bring that second piece down so we can FOIL this one together with it. 4 plus 5i, okay? Remember, guys, we have to make sure that we are distributing in order and make sure that we handle that square properly, okay? Please don't ever write 2 squared minus 3i squared. That's terrible. So let's distribute this. Negative 5 times 4, negative 20. And we've got negative 5 times 5i minus 25i minus 48i, and finally minus 60i squared. Okay, let's keep simplifying the same way we have been, right? So middle two pieces will combine, and we should get this is negative 73i. I squared, again, this is just negative 1. So that's going to flip my sign. Negative 20 plus 60 becomes 40. And here is my final answer, 40 minus 73i. Okay, so distribute, simplify, distribute again, simplify again, and we've got our answer. Okay, always be careful to FOIL out and never leave your answer with that I squared. All right, complex conjugates. Now, this is kind of an interesting one. Complex conjugates are talking about kind of a partner for imaginary numbers. Okay, and if you remember in the quadratic formula, there's always this plus minus, and that's kind of why we have complex conjugates, because inadvertently, every time we take a square root, we know that things are usually plus or minus, right? The square root of 4, plus or minus 2. Well, when we take a square root and get an I, it comes with that plus or minus as well. And that's where that complex conjugate kicks in, all right? So we look at a plus bi, a complex number, and its conjugate is always the same numbers but with the opposite sign in the middle. Okay, so a real quick example, 3 plus 2i, and the conjugate is 3 minus 2i. Okay, so this is the conjugate. Notice I do not flip the sign on that 3. Okay, only the imaginary part gets that sign flipped. Okay, and there's a kind of interesting way that these interact when we multiply them together. Let's see how that works, okay? So first thing, 6 plus 8i. Let's find that conjugate. So what is the conjugate of 6 plus 8i? I'm hoping that you guys all came up with 6 minus 8i, okay? Now, if we FOIL this out kind of the long way, as it's mentioned, 6 times 6 is 36, 6 times minus 8 minus 48i, plus 48i, and minus 64i squared, okay? And you're going to notice, look, these are going to cancel out. My I squared is going to make this become a plus, okay? And I end up with 36 plus 64, which is just 100. Kind of interesting, all right? And there is a shortcut to this, okay? And there's a shortcut you can do foiling it out. You can realize, hey, this is a special pattern. Remember your factoring pattern? A squared minus b squared is a plus b times a minus b. Well, guess what? This is the plus b minus b side. So this is actually the right-hand side of my equation, which means all this is going to be is 6 squared minus 8i squared. And overall, it always just leads you back to this. 6 squared plus 8 squared is 10 squared, or 100, okay? So key thing here, you can kind of shortcut a plus bi times its conjugate, or it's not a ton of work, you can just multiply it all the way out, okay? And that I always ends up flipping the sign. So shortcut, if you have a plus bi times a minus bi, you always just end up with a squared plus b squared, okay? But if you don't remember the shortcut, you can always just do it out the long way. Okay, dividing with I and simplifying. Okay, guys, I is a square root. Okay, we already said I is the square root of -1. So all the rules for square roots apply here. We never leave one in the denominator of a fraction, okay? And so what are we going to use to help us rationalize it or fix that fraction? Well, we can always just use the complex conjugate to help us fix it, all right? So let's do an example of this. So the first example reads as 6 minus 7i divided by 1 minus 2i, okay? So this is the I care about. I don't want that I down there. So here's what I'm going to do. I'm going to go ahead and take this bottom part, and we're going to multiply it by 1 plus 2i, right? This is the conjugate, all right? And you guys know, can't multiply the bottom without multiplying the top. So same conjugate, okay? Don't use anything else. Got to have the same thing on top and bottom, okay? So we're going to go ahead and distribute this out. Now the bottom, when I multiply the conjugates, I'm going to shortcut a little bit using my shortcut, a squared plus b squared. So here we go, 1 squared plus 2 squared, okay? This top part, I'm going to go ahead and have to distribute out, okay? So we've got 6 plus 12i minus 7i and minus 14i squared. Let's simplify this, okay? So 12i and 7i, those two are going to make 5i. So this I squared is going to flip this to be a plus 14. And overall, I've got this. 6 plus 14 gives me 20 plus 5i over 1 plus 4 is 5. And hey, I can actually divide this down. This reduces, which is kind of cool. So we'll reduce this, divide each of these by 5. And we've got 4 plus I. Okay, so this is when we reduce. Okay, so make sure that this top part we have to FOIL. And then we simplify. Okay, and we get to our final answer. Again, This bottom part, you can shortcut or you can just multiply it out. Either way, you should get to the same result. Okay, so if you're feeling good about foiling these out and distributing, go ahead and start with this next problem. Remember, we're going to need to multiply this out. So let's start by simplifying this bottom piece before we rationalize. 4 minus 2i times 4 minus 2i. That's just the square. And as we multiply this out, let's see what we get. I came up with 12 minus 16i for that denominator. So currently, here's where I stand. 3i over 12 minus 16i. Okay, these denominators are the same. All I've done is FOIL this out, right, and simplify. So just remember, no I squareds. We got to get rid of those I squareds. Okay, now let's fix this. Again, I've got this I in the wrong spot. That's no good to me. We got to fix that up. So let's multiply by the conjugate. What's the conjugate of this bottom part? 12 plus 16i. All right, and top and bottom got to go together. 12 plus 16i. Awesome. So let's distribute, okay? On bottom, 12 squared plus 16 squared, okay? And 3i is going to distribute in here, 36i and plus 48i squared. All right, let's simplify what we've got. So first thing I see, that I squared, that's just going to make this a negative 48, okay? And 12 squared is 144, and this is 256. So here we go. Here's what I've got. Negative 48 plus 36i, okay? Notice I rewrote it in order, okay? I always comes last. And 144 plus 256, that should just give us 400 at the bottom, okay? Now, cool, we've got our fraction answer. Let's just reduce it. This does divide down, so it's always nice to reduce our fractions. What can I divide this whole thing by? Well, at least 4 will come out of here, so let's go ahead and divide these all by 4. So this will be 100, 9, and negative 12. And my final answer, negative 12 plus 9i over 100. And that's it, okay? Now, you can separate it out into multiple fractions if you want. You could make it negative 12 over 100 plus 9i over 100. But in this case, that's our result. All right, let's write some complex numbers in standard form. Remember, standard form is a plus bi. So we're going to always put that real number part first and the I portion second. Here's what we've got. Watch out. This root 3, that negative is going to make an I. So here we go. I square root 3 and I square root 12. Multiply these two together. Let's see what we get. I've got I squared square root 36. And you guys might look at me funny, but look, I times I gives me I squared, and 3 times 12 is going to give me that 36. Now, let's think if we can simplify this any further. What's I squared again? That's right, it's negative 1. And what about square root of 36? Isn't that just 6? So here we go. My final answer ends up being negative 6. Okay, negative 1 times 6 being negative 6. All right, let's take a look at this next one as well. Now, this next one's a little bit trickier because of breaking down these radicals. Okay, so pay close attention to this. Negative 48 Okay, let's go ahead and just change that to being an I out in front. Now I'm gonna do the same thing with this 27. Let's take that I out. So can we break these radicals down into something that at least matches? Ah, let's see what we can get. So if we factor the 48, and we're going to discover maybe 48 breaks down into 4 and 12, which can break down further into 4 and 3. Okay, so I see this pair of 4s, so I'm going to take that out, and this 3 goes back inside. Okay, I'm hoping this is kind of familiar. So continuing my problem out here. We've got I times 4 times square root 3. Okay, and this kind of nicely written is 4I square root 3. Okay, let's do 27 as well. We're going to break the 27 down the same way. So 27 is 9 and 3, which could be 3 and 3. And I'm like, wait, I see a pair of 3s. Now notice that third 3 is going to have to go back inside. All right, so minus I times 3 square root 3. Okay, broken down radical. So here we go, minus 3I root 3. Now notice that I square root 3 portion is common between these, so lovely. I can subtract 4 minus 3, and I'm going to get 1I root 3, and we don't really need to write that 1 there, so let's get rid of that. And we're just going to write I square root 3 as my final answer. Okay, so I did have to break the radical down and simplify it before I could get this. Okay, all right, last one, 1 minus negative root 3 squared. So, okay, example 3 is kind of a fun one. It's got a lot going on in there. Okay, so we've got negative 1 plus square root of negative 3, and the whole piece is squared. So let's go ahead and expand this out, and let's pull that I out while we're at it. Okay, so here's my expanded form. Negative 1 plus I root 3 negative 1 plus I square root 3. And we're going to go ahead and FOIL this out. Let's distribute. So negative 1 times negative 1 is 1 plus, or should say minus, I root 3 minus I root 3. And when I multiply these last two, I square root 3 times I square root 3, we've got plus I squared square root 3 squared. And it looks a little bit funky, but it's going to simplify down pretty nicely, actually, because I squared is negative 1, and square root 3 squared is actually just 3. So we can just get negative 3 out of here, just minus 3. And the rest of this, we'll just go ahead and combine these together while we're sitting here. We got minus 2I root 3 and a 1. And now I'm noticing, I'm like, wait a minute, I got two whole numbers. Here's a 1 and here's a minus 3. Let's put those two together as well. And we're going to get a pretty nice looking answer here. Negative 2 minus 2I root 3. Okay, so they mixed a lot of stuff in that one. We had to FOIL it out, had to simplify it, and make sure to pull out that I. Make sure you put that front number as being the real number and the second number as the part with I, your complex number. All right, let's look at some solving equations and getting I as an answer, right? So this first one is pretty simple. X squared plus 4 equals 0. And we can just start solving it like normal. Subtract our 4 to the other side. X squared equals negative 4. And you're already seeing, like, you normally freak out and just say, hey, this is not a real answer. But we're going to go and take this square root. And we've got x equals plus or minus the square root of negative 4. And now we can be like, wait a minute, this turns into plus or minus I root 4, which is just 2I. So plus or minus 2I is my final answer. Okay, so I did take a second and say, hey, let's show that extra step, pulling the negative out with the I. But all we're saying is, hey, when you square root a negative, that's going to turn into an I for us. Okay, and the root of 4 is just 2. So this example was pretty simple in that there wasn't a lot of complicated math. We just had a negative number and took a square root. So we got a plus or minus I value. Our next example, this one has a middle term and it's not something we can factor. So unfortunately, we're going to end up using our quadratic formula, right? So last week we solved some problems using the quadratic formula. So let me remind you what it is. Negative b plus or minus the square root b squared minus 4ac divided by 2a, okay? And if we went in order, you know that our numbers a, b, and c are going to come from this equation, a, b, and c. Okay, so take a second, go ahead and plug in your numbers, see if you get the same result and same setup that I have. So in purple over here, I've kind of plugged in all the numbers. Let's simplify this down into something a little more manageable. So this first portion, the two negatives are going to cancel out. Negative 2 squared, right? Notice I put those parentheses. That's really important. That's going to give me a 4, okay? So we've got 4 minus 4 times 3 is 12 times 5 is 60, okay? So overall, my root has 56 under it. And down here, 2 times 3, that's just going to be a 6. Okay, so here's where I'm at right now. 2 plus or minus square root of negative 56. Okay, put that negative sign up there too, over 6. And we can kind of break this square root 56 down. Okay, I'll do it off to the side over here. So the negative is going to come outside and become an I. And 56, we can break that down. Let's say we come up with 2 and 28. Just keep breaking it down. Maybe we've got 2 and 14, 2 and 7. And here we go. These 2's, I'm going to take a 2 out. It'll be nice. And the rest of this 2 times 7 is going to go back in there. Okay, so 2 is coming outside. Here we go. 2 plus or minus 2i. And inside my root, 2 times 7 is 14. Over, that's 6 still. Finally, let's reduce this down into something a little bit manageable. I'm going to divide all of these by 2. And my final answer, 1 plus or minus I root 14 over 3. Okay, again, we could split it up into different fractions, but this is good. Okay, so hope this video was helpful to you guys. This covers all the content you need for complex numbers, okay? So starting with adding, subtracting, and equalities with complex numbers, understanding how exponents on complex numbers work, how to FOIL and distribute them, and how to even solve equations with them, all right? Good luck and happy studying.